Welcome to Chapter 6, Chemical Equilibrium. Now we are going to learn about Kp and Kc to solve equilibrium problem. So this is the relationship between Kp and Kc. Okay, so when you write the equilibrium constant expression for Kp, Kc, and then assume that it is ideal gas. So we know ideal gas is Pp equals to nRT. Okay, then find partial pressure because here are all partial pressure. Okay. And then after that, just now have shown that concentration RT, substitute inside, and then eventually you will get Kp equals to KcRT delta N. Okay, this is the change of mole. Okay, what does it mean? It means that the total number of mole of products minus total mole of reactant. Now let us look at one example to understand better, to use the Kp and Kc to solve equilibrium problem. Now, if NaHCO3 is placed in a closed container, remember reversible reaction must be in closed system. Carbon dioxide and water will not escape. Given the concentration of carbon dioxide and water at equilibrium at certain temperature, calculate the equilibrium constant Kc and Kp for this reaction. So first thing, always write the reversible reaction, and then remember, don't forget the phase, because we know if it's solid, we are not going to put it in the equilibrium constant expression. Now we are asked to find Kc and Kp. So how do we begin? Okay, we begin by first writing down what is the information given. Information given is molarity, means concentration at equilibrium. So at equilibrium, molarity, solid, no concentration because it is constant, and then gas given is 1.5 molar. Carbon dioxide is also 1.5 molar. Then what can we find? We can find Kc first, because Kc, the expression is product over reactant. Now, because the reactant phase is in solid, so we do not include the reactant. So we only have product. So for product, we have water, vapor, and carbon dioxide gas only. So it is equals to 1.5, 1.5. So we will get 2.25. So we have find Kc. Okay, next one. How to find Kp? Okay, so in order to find Kp, we don't have to calculate one by one for pressure. So what we do is we use Kp equals to Kc RT delta N. Okay, first of all, let's look at temperature. Temperature given is 25, meaning that it is 25 plus 273. We are going to get 298 Kelvin. Okay, so we have this. Now, another one is R. So which gas constant shall we use? So we shall be using 0.08206 because it involves concentration. Okay, now let's substitute what we have. So we have 2.25 from the calculation we've got, and then R is 0.08206 times 298 Kelvin. Remember, temperature must be in Kelvin. Okay, so what is the delta N? Delta N, just now we have said that it is product minus reactant, and it is the total number of mole. Now let's look at the total number of mole for product and reactant. Okay, for product, we have 1 mole, 1 mole. Okay, so total mole of product, we have 2 mole. Reactant, we don't have any mole at all because there is no aqueous or gas involved here. So it is product minus reactant. So product is 2, reactant is 0. So we've got 2. So substitute into the expression, and then the final answer, we will get 1.35 times 10 to the power of 3. Now, again, remember, write the expression, 1 mark, substitution, final answer, no unit. Kp and Kc, substitution, final answer. So when you can calculate Kc, then easily you can calculate Kp by linking them with KcRT delta N. And also don't forget that this is reversible reaction. So we use this formula, and then the number of mole is product, total of product minus reactant. So that's all for the using the formula of Kp equals to KcRT delta N to solve equilibrium problem.